All right, so now we are going to start again. Actually, I figured out that if I want to get the room quiet, I just need to speak about the exam. And if I start giving information about the exam, then suddenly, yeah. Oh, is it not working? Oh, I need to let you in again. Yeah. All right, so we are going to start again. I just need to make Dalia a moderator so that she can let people in. And now we can start again. So where were we? We were talking about this lady right here who discovered something. She studied the galaxies and she was looking at how fast the galaxies rotate. You know that it's not just the Earth that revolves around the sun, right? That was the Copernican revolution. It's also that all the stars in a galaxy, they also turn around the black hole. Now we know it's actually a black hole in the center of the galaxy. Sagittarius A star, I think, at the center of the galaxy. And so we want to know how fast they rotate, and Vera Rubin looked at it, and she measured the speed at which it's rotating, and she also used the relativity theory in order to predict the speed at which it should rotate. And she had a big surprise. She had a big surprise because the speed at which the galaxy is actually rotating is much, much higher than the predicted speed. And that doesn't make sense. Right? That doesn't make sense because based on what we see through light and electromagnetic wave, it should rotate slower, but it doesn't. And so a lot of people checked and they actually figured out she was right. And so this is why she was credited for the discovery of dark matter. Dark matter is what we call this invisible matter out there that we have absolutely no idea what it's made of. We just call it dark matter. But the scary part is that in all the matter, matter and energy is the same thing, right? Einstein, E equals mc2 is the same thing. But the only thing we know about the universe is 5% of that. 95% of the universe, we have absolutely no idea what it's made of. We know that roughly 20–25% is dark matter. We know that 70% is dark energy. That is what causes the expansion to be faster than we think. We only know 5% of the universe. And so because of her discovery, an observatory was built in Chile. And the goal was initially to analyze dark matter and find out more about it. And then people realized actually the observatory that is being built, first, it was renamed in honor of Vera Rubin. But second, we can actually do so much more than just dark matter. We can, in fact, take a snapshot of the entire sky every couple of days. That's just amazing, right? That we've never done that before. Every couple of days, a new snapshot with automatic detection of anything that moves. And that's millions of times every night that they think this is going to happen. We will know immediately when we see something moving in the sky. I don't know, maybe a supernova that is starting or whatever, but this is very exciting. And just to give you an order of magnitude of what we are looking at, 20 terabytes per night. Last year, I would have said that's one hard drive per night. Now it's 10% of a hard drive per night, but still that's still a lot, right? So 20 terabytes per night. So we are going to have hundreds of petabytes of data and maybe even more. I listened to a talk by Thomas Zurbuchen, who is a professor at ETH. He was scientific director of NASA before. He was also talking about hundreds of petabytes of data for satellite observations that they were doing around the Earth, right? So it's just very common and it doesn't fit on a machine. We need data centers for this. Next, I wanted to say a few words I already did about DNA as a storage layer. This is, again, data independence. The power of data independence is that it doesn't matter where you store the data as long as you look at it from the modeling perspective, in that case, the table. So it doesn't matter if the table is stored on a computer or on a data center or on DNA or even on a clay tablet, it's still a table. That's the magic of data independence. And so now there's these technologies of using DNA. Several reasons. First, the density. You know, I told you we have this hard drive of 245 terabytes. That's 1 trillion times more dense than what we had in the 50s. This is nothing compared to what's going to happen with the DNA. This is going to be yet another massive increase of the density of data. Plus, this is extremely stable. I mean, this is why with evolution this came up out of nature. This is extremely stable and can last for a very long time. All right. So now, zooming back into the course that we have, you know this thing that's probably again coming from consulting slides. You know these things like data, information, knowledge, wisdom. So it's a pretty famous sequence of words. Basically, the way I see it is that everything at the bottom here is basically the database systems, databases. And then if you go a little bit up, you start going into machine learning and then into AI, which I have absolutely no idea about because I specialize in databases, so I wouldn't be able to tell you much about AI. But this is not in the course, right? There's so many other courses at ETH that cover these things. We are going to explore databases. By the way, since I'm at it, you must understand the difference between database system, and database management system. Who knows the difference? So let me tell you. A database, that's the data itself. The clay tablet is a database. A book is a database. That's the data. A database management system is a process or a piece of software that manages the data. That can be the PostgreSQL that you install on your laptop. That's a database management system. That can also be in a library centuries ago, the system they used to index the books, right? It's just a database management system. A database system, that's the two of them together. The database plus the database management system is the database system, right? One other thing to remember for later, because many people say database to actually mean the database management system. All right, but now is the time to introduce to you the wonderful TA team that we gathered this year in order to transmit all this knowledge to you. And they are here. Many of them are actually here. You can stand up now, maybe come in front, all the TAs who are here. So maybe we can start with an enormous round of encouraging applause for the TAs. Right, so you will see they are awesome. They are very dedicated. You will see them in the exercise session, and they will take very good care of you. There's more actually. There's many more here on the slides, but you will see them. I will say a few words about exercise groups and so on. Right. So thank you very much for being here with us. And Zikai here is the head TA. Right, so he couldn't be here today with us, but you will also get to know him very soon. Have I talked about Ethel? Who knows about Ethel? Well, some of you know where to find her, right? ethel.ethz.ch. It's an AI model. It's an AI model homemade here at ETH, Gerd Kortemeyer from the rectorate. It's using existing models like OpenAI, probably at some point also Apertus. But basically, this model, which we control, has been fed with lecture material. So the textbook, I'm going to show it to you, the textbook of the lecture was fed into Ethel. And you can interact with her and ask all the questions you want about the textbook, and that can be a useful tool. Critical thinking, be careful. LLMs can hallucinate. You probably know about that. But still, it can be very useful to point to information you're searching. This is a very powerful search engine, right? So I consider her part of the team as well. I call her an AI student rather than a TA for now, just because of the hallucinations. But who knows? Maybe in a few years, AI will reach TA level. All right. We might be able to also, but this is experimental, so that would be the first time. Gerd Kortemeyer told me it might be possible to integrate her into Jupyter notebooks to give some feedback about what you're doing in the notebooks. We don't know much yet, but this is going to be investigated. Maybe some of the TAs will want to look into this, and that might be an even more enhanced way of interacting with Ethel. Okay. Then what are we going to do in this lecture? So many different things. We are going to look at how to store data in the first few weeks, so the data storage devices and formats. We're going to look at data models, tables, trees, and so on. So the importance of having a data model, that's part of data independence, because your data model is the interface between the data independent logical view and the physical view. And then, and that's actually my favorite part, this is when we process the data. Hadoop, MapReduce, Spark, and so on. The coolest part, where we will see when we let the data flow in the cluster. And then we'll focus on the management with document storage when you start to build a data store around this. And then query languages, we'll see that SQL is great for tables, but it reaches its limits if you want to use it on other shapes, denormalized data like trees, graphs, cubes. SQL is no longer the appropriate language. So we also look into this. And here I put a few buzzwords so that you can have Vorfreude, as we say in German, and be happy in advance about what is awaiting you right here. I am so looking forward to it. I love all of these buzzwords. All right. What is expected? So first, you're going to get 10 credits out of this lecture. KP is for Kreditpunkte. What is expected from you is the attendance of the lecture, what you are doing right now, right here today, and tomorrow at 9 a.m., even though I suspect there will be more people on Zoom tomorrow because it's actually quite early. So attend the lectures. Then you have the exercise sessions on Wednesdays and Fridays. We will let you know what groups we have. There is no exercise session this week. You don't have to worry too much, right? It's going to be next week. And by then, we'll have figured out the assignment of the rooms based on the registrations. We have more than 500 registered students. So we are working on the exercise groups. And then we will inform you. You will still have a small assignment this week that TK has been preparing to test with a quiz that doesn't count. I'll talk about the bonus points, and for testing the Docker. I'll tell you more about that. And then, of course, Rabbi, let's not forget that. You're supposed, because 10 credits is a lot. That's a lot of credits. So we expect you to self-study, to read the entire textbook, to read the material, read the books, play with the technology, codes, play with the tools. This is very important to make yourself familiar with all of this. And you will be surprised at how much you can run on your laptop. Because in fact, what happens in the cluster is not so different from what is in the laptop. And I'll say a few words about that, but it's very useful, especially if you create a startup. You should start on your laptop. In many cases, it actually fits on it. It's less costly, and that's a great way to start. And then you go to the cluster once you have to put it at scale with the petabytes of data. Anyway, we'll have so many weeks to talk about these things, but you need to read and to play and solve the exercises, the practical exercises. The TAs did a great job at preparing all of these amazing exercises. And finally, the scary part, the exam at the end. 3 hours. 3 hours is not to bother you or scare you, it's just to give you time. Because we designed the exam in such a way that you can actually solve it in less time. But 3 hours gives you a bit more time to proofread your answers and so on. What I promise every time is no more than 60 questions, 60 multiple choice like questions in Moodle, not 60 essays, 60 small questions. All right, and this is going to be in January or February, but we'll have plenty of time to discuss the details of the exam. It's going to be on a computer in Moodle, but since you will have Moodle quizzes during the semester, that should not be unfamiliar to you. All right, and if you pass the written exam, in fact, I put all of that too, but this causes this. hopefully. And then if you pass the written exam, then you have, I could almost teach statistical causal inference with this. But anyway, you pass the exam and then you get the 10 credits. Bonus points. This is a system that was standardized at ETH to give you an incentive to follow the course and solve the exercises during the semester. It's your chance to get up to an additional quarter point at the exam. So if you want to get these 0.25 bonus points, we cut it into smaller pieces of 0.01 because we think it's cool. And so we have 25 quizzes. It's not the same as information retrieval, right? So be careful. We'll have 25 small quizzes, and every one of these quizzes gives you 0.01 extra points that you add to the grade. But now you're going to tell me, yes, but at ETH, we only give quarter points, right? We do the final grade. So what happens if you don't get the full 25? Well, what happens is that before the quarter point, we have a raw ETH grade that is computed out of Moodle. Then we add the bonus points, and then we round to the nearest quarter points. So it means that if you get the full 0.25, you have a probability of 1 to get an increase at the exam, except if you got a 6. Let's not push it. But if you get less than 25, you have some probability of getting an increase on the grade, depending on the rounding, right? So to maximize your probability, you should solve as many quizzes as possible. One more thing about the quizzes. The goal of the quizzes is to push you to think and learn the material. I would, how can I put it? I would advise you or recommend that if in one of the quizzes you're not happy that your answer wasn't accepted, or you think you have a very strong argument and so on, then engage with the TAs. Engage with the TAs, write an email, send your arguments, right? And these are very interesting conversations. And then if you manage to convince the TA team, then maybe the answer can be accepted for everybody, of course. Then, so it's a very good opportunity to interact and argue with the TA team. Once we had a guest lecture of Databricks in the lecture, and he was saying that the goal of education, master, PhD, and so on, is to bring you to a level that you could have a conversation or a debate even with a Nobel Prize or a Turing Award winner or Fitzgerald, right? So this is the goal. And so practicing the argumentation of, making your argument of why you think your argument is correct, that's a very good exercise. So try it with the TA team. They are really good. So don't hesitate to have a conversation. Okay? What did I want? Oh, yes, I know what I wanted to ask. It's why I got a request, and I'm not sure we can do something about it, but I would like to at least get an overview, because, if you're not Swiss, maybe this is not familiar, but in Switzerland, there's a military service, and for some of the Swiss students, it might be during the semester, which means that you might be away for a couple of weeks and you cannot solve the bonus points. And so I got asked, and so I wanted to know how many of you are actually in this situation. If it's too many, I'm not sure we can do a lot, but if it's very few, maybe we can find a way. So just in order to understand. So this is no, if you're not Swiss or you're not in the military service, then or if you don't know what the question is about, then you just say no. Ja, ich habe een WK, aber es gibt kein Problem für Bonuspunkte. If you're not worried about this, that's it. You can still solve them while you're in there. And this is if you actually are worried that you will not be in a position to solve them. Gaan we de eigen piece maken. Only 6, so that's actually not such a big number. It's actually good. How many answers in total? 179. That's not half of the course, so probably that would be 12 or 15 in the whole course. Okay, we'll take this data. I cannot promise anything, but we'll discuss with the TAs if there's anything we could do about it. Maybe not show the solutions right away to give you time to come back from the VK to solve them, or we'll see. And option 4, actually, I don't know. I meant to delete it, but anyway, okay. Great. So this might be manageable, but again, we'll tell you if there's something we can do. Then, by popular demand, a couple of years ago, in the course feedback, I was asked if it would be possible to have a textbook for the lecture, because there wasn't any textbook available that actually covers these things. And so we used to have plenty of papers and various chapters all over the place. And so then I started a textbook, and it's 400 pages roughly. It's there. So this is the printed version, but you don't have to buy, and you shouldn't buy the printed version because you have a PDF that is available online. You just need to go to the address right here. It's in some research publication portal, and you can download it. And why should you use the PDF? Because I keep updating it. When I receive feedback or there's typos or things to fix, I keep updating the PDF. I'm not able to update the printed book, but the PDF, I can update it in real time. So this is why your preferred way of using the textbook should be the PDF that you can download here. Anybody in the world can download it. It's just free for the whole world. Anybody can use it. Thank you. All right. Then we have the Moodle, which is the material of the course. It's the slides of today, the exercises, the practical exercises, the theoretical exercises, information about the exam, the Docker files, and so on. Everything is in there, and that's accessible from your ETH account if you are registered to the course. So you need to register for the course in My Studies, and then it gives you access to the Moodle. If you don't manage to register in My Studies because you're still waiting for some paperwork, drop me an email. I can still add you manually to the Moodle, and then you can register later. Be careful because the registration for the exam is another registration. It will open in a couple of weeks, but these are two separate processes, right? So registration to the course gives you access here. Registration to the exam registers you for the exam in winter. Okay, that's the Moodle. Then we'll use software. We'll use a lot of, to query with SQL, to query with JSONiq, we'll use Python a little bit, we'll use Spark, MapReduce, MongoDB, and so on. And so in order to ease things a little bit and to keep it manageable for the TA team in terms of support, because of all the operating systems, we are using Docker. Docker is just some standardized software in such a way that we just give you a file, you download and install Docker on your machine, and then it should work for everybody. I said should, I didn't say will, because that's reality, right? But usually it works for most of the people, and so this is what we would use for the course. And of course, if it doesn't work, the TA team is here to help you, and we will investigate. There might be also other solutions with other platforms. So yes, you will receive. So let me give some high-level overview. We have one Docker file that actually maps the exam environment, what you'll have on exam day. PostgreSQL, PySpark, Spark SQL, and JSONiq. And we have a Docker file that has all of that, plus all the data sets of previous exams, and we'll also give you the data set of this year's exam. So there is a Docker for that. It's also going to be used in many of the weeks of the course, but in some of the weeks, there might be a different Docker file because that's a special configuration, right? But then you will know it will be stated on the website, on the Moodle. Now, in case Docker doesn't work or you run into errors, it's the IT crowd. Have you switched it off and on again? And this is literally what you need to do. If it doesn't work, then you delete your containers, your images, and your volumes in Docker. You can do it in the UI, and then you start again. It's a simple command, Docker compose up, then it should just work. All right. That gives some predictability for the exam, because students like to know in advance how the exam computer is going to look like. So that's why we made that. Then, some of you might have noticed, we have a chat platform that is open to everybody in the course. It's hosted by ETH, doesn't leave the ETH servers. You just need to go to chat.ethz.ch with your ETH account. Then you pick chat for students right here, and you should see the room of the course. It's called Big Data Town Square. So you can go there, you can interact with each other, with one another, with the TA team. Some people like to post memes. It's totally fine. If you have memes on databases, there's pretty cool ones actually. So it's totally fine. There's also the Moodle forum, and the TA team will inform you about what's the preferred way of asking questions. So there's a Moodle forum as well, where a bit like Stack Overflow, where you can ask questions and get answers. What we encourage you to do when you have questions, it's always better to ask them on the chat or on the forum than send emails. Why? Because if you ask in the public forum or the chat, then other people see your question and benefit from the answer. So there's a conversation in the course. So it's very beneficial. All right. So I spent half an hour this morning, because it's very slow, inviting the whole class. If it didn't work or you registered later, then drop me an email with your username of ETH, and I can add you. All right, so that's the ETH chat. I know that there is a Discord server for the students, but this is a different platform, and I think usually the lecturers are not on this platform. All right, and then I have a fun task for you. If you like to play, of course there will be Docker for everything, so you don't have to worry too much. But there is something new that we managed to do this summer, because one of my colleagues, Abhishek Ramdas, managed to find a way to make JSONiq work in Python. JSONiq is what we use in the course, as the glue of everything to query data on HDFS and S3 and so on. And so we managed to make it work in Python, and now it's just pip install JSONiq, and then you can use something similar to Spark to build it, and then you can put this query. This is, of course, a very basic example, but you can also have multi-line queries and query it in Jupyter notebooks. So since it's very new, I'm very interested in feedback. So if you have time that you're bored, you don't know what to do, then try this, not with Docker, but really on your machine. If you have Python, try to install it. And really drop me any error messages, issues that you have. Drop me the screenshots, tell me your operating system and so on. I really want to see an overview of how that works. So the documentation is right here. The only thing you need to know really is that it needs Java 17 or 21. So if you don't have this version of Java, you need to set Java home. If you do not have any version of Spark installed, it should just work. If you are already using Spark somehow on your machine, then there might be collisions. And so here too, we try to put the error messages to be informative. But anyway, if you want to have fun, try it out and drop me an email. Even if it works, I'm always happy to hear that it worked for me to get an impression. Because the goal is to stabilize it and make the error messages informative over time. Okay? Then I have another question. Oh, yes. I'm going to be asking that every time. That's your remote control. That's basically your way of accelerating me or slowing me down, right? If you say, oh, I understand everything, it's so easy, then I can go faster. And if you say, oh, I'm completely lost, I didn't understand what you told me, then I can slow down, explain more and so on. I adapt to you. In some lectures in the last semester, it was interactive, and I even adapted the class to the question you were asking or the direction in which it was going, right? So I can adapt a little bit. There's anyway the textbook with the linear lecture, so I don't need to be exactly linear in the lecture compared to the textbook. And so first, I'm very happy when I see these kind of numbers. I don't expect every week that there will be a lot of people in this category of everything. My goal is to basically be in this area right here. So many people above 80, at least many above 50. And if it goes in that direction, then I can, that's okay, you're following. And if it goes a bit like this, and I can tell you there will be a few weeks that are a bit tougher, like the week on HBase. I don't want to scare you, but the week on HBase is a bit tougher. And then it's okay, maybe it's going to be a bit to the right, but I'll adapt and answer questions. Okay. So at least we have the confirmation that menti.com is working and that I didn't lose you just yet.